welcome to second semester, huh? Hope you all had a nice time off. I've yet to run into a kid. Yet to run into a kid that says, "Boy, I didn't like my break."
But you're gonna stay today.
What I do?
He said he stayed to church today. He almost not said sir gonna stay today.
All right, so you will need to find yourself over to the bookstore and find this book. It's blue now. No, it's $5.
$5?
$5. So I will have this week covered. So if you need to hold off or figure out where your money went, because mine went to, let's see, places I ate over break. I went to In-N-Out Burger. In-N-Out Burger. In-N-Out Burger. And I ate In-N-Out 4 times when I was down in Arizona. So it was yummy. I loved it. If you've never been to In-N-Out Burger, you're missing out. Yes, supposedly it's coming to Colorado. Yet to be seen. But who knows? If it does come, it'll be good. I can tell you when I lived in Nevada and it came to Nevada, for about 6 weeks, they always had a 2-hour wait. Didn't matter what time you went. Just for a burger. Supposedly. So a few things that are nice about when a semester starts new, starts fresh. You start new grades, okay? Your grades don't roll over from first semester to second semester, so whatever you wind up with first semester doesn't mean that's what you're starting with second semester. Let's figure out some nuts and bolts that I do. So I think if you don't remember, I'm Mr. Stirrup.
I think we all remember that.
I love you. Of course, it's always okay just to call me Stirrup because the surname Mr. That's my daddy down in Arizona. Let's see, what else? The cell phone policy. I take and give to Dean. Okay, so just make sure if you are addicted to your cell phone or you got something brand spanking new and you can't put it down, well, I might force your hand on it, and so go to the dean. So please don't get caught up in that. What else? This is 22 years. I'm more than 22 years into teaching, so I think this year I might learn it best. So hopefully. So there's a lot of times with math we have errors that we see over and over again as teachers, so we try and point those out so you all don't make those kind of errors. On Schoology, on my page, on Schoology for this class, I will have the notes. So if you need a copy of the notes, you can go there and you can print them off. I will provide you notes, but if you wanted the ones already filled out that we fill out in class, they'll be there. And I also will have the video of all of my lectures put there. So if you happen to miss class for whatever reason, and you come and see me the next day saying, "Hey, what did I miss?" my first question to you will be, "Did you watch the video?" And if you say no, I'll say, "Please watch the video first and let me know if you have any questions." Okay, so those are just a couple of ins and outs and neats and bads. Let's see, what else seems, huh?
No headphones.
Yeah, headphones fall under the cell phone, so headphones. And the excuse, well, I don't learn that way. Trust me, I've taught long enough that I can understand that if you're blaring music into your ears while you're trying to do math, they don't go hand in hand. You won't listen to the kind of music that you would need to listen to emphasize the neurological pathways in your brain in order to develop the skills needed. So I won't let you use your cell phone or your headphones during class. It's disrespectful. I don't have them in. I expect you not to have yours in either, okay? And it always makes me laugh when it says, well, I learn better when I have headphones in. Believe me, I could go back and take a look at past grades. A lot of times that kid says, hey, I learned better with a headphone in, and I'll look back saying, wait, you got a 36% last semester? You really think you learned better that way? Like, what would you have earned in my class? What would you have earned in my class if you didn't wear headphones or earbuds? Okay, anything else? Anything else that we need to focus on? I have a bad sense of humor because of what reason? I laugh when people fall, right? Good.
And you'll see him next week.
We'll see you next fall, right? Yeah, have a nice trip. See you next fall. Isn't that fun? Okay, anything else? Yeah, well, let's get away. So, students sometimes ask, excuse me, do I need to keep my notes and homework from last semester? The answer is no. The reason the answer is no is I will never say to you, well, why don't you refer back to the notes on writing lines of best fit? So I would say, recycle your stuff. Is this semester hard? No. No. But the sad thing is everyone has a grade of U right now. Yeah, it's an undefined grade because you have 0 out of 0 points, which is an undefined grade.
Wait, so we can throw away
Toss all the old stuff. You don't need it. I'd say put it in the recycle bin so we can. Looks great. Recycle bins up front if you want to use that. Don't throw away the notes I just handed you. Okay.
Throw everything away.
Yeah, you don't need.
I'll do that.
Recycle it though. Recycle it. All right.
We can throw away our books too.
Yeah, because there's no one to go get. No one to go get. There's recycle up front if you believe in recycling. If you don't believe in recycling, put it in the trash and then it'll compost and turn into fossil fuels that will later utilize as coal in about 1,000 years. All right. Are you ready? Are you set? So, some of you have claimed that you have a new philosophy of how you're going to do, and you're going to do better. That's awesome. Oh, love that. You okay? That wasn't me, was it?
Okay, yeah. I feel like my handwriting's just gone. Probably, I don't know.
I wonder if I would like answer this one. I got my back to the point.
It's funny. It's okay though.
Me either. All right, I think my glasses are clean until I put them on and I look through it and see thumbprints on it again. All right, are we ready to start? Here we go. So we're going to focus on exponential functions and sequences. Okay, so it's just big words. It's not hard. The larger the word in math, the easier it actually is. Absolutely. So, what do you remember about an exponent? Is that extra? Still can't count. That was my New Year's resolution. I'd be able to count. Almost. What do you guys and girls remember about an exponent? What is an exponent?
What's your number?
What?
What's your number you multiply?
Yeah, is it
It's a square.
like a square? Yeah. Cube? A root could be a type of exponent? Absolutely. So there's two properties that we're going to focus on today. We're going to focus on this first property and this second property. And we're actually going to refer back to this for the next couple of days to ensure that we have all of the properties down. Now, so those of you who are filling in calendars and figuring out stuff, this week we have Tuesday, Wednesday, Thursday. Tuesday, Wednesday, Thursday, Friday, right? We don't have any tests or quizzes. Yeah.
We need another one.
I could count it.
Yeah, no, ours ripped when we were handing them out. It ripped when I gave them it. So like we have each other.
Yeah.
So you can't
You want
tell
this?
me your
Yeah.
resolution.
I was gonna go back to 17. All right. So we don't have a test or quiz this week. Next week we don't have school on Monday. We have Martin Luther King Day, great day off, 3-day weekend. The week, all of next week, it does not look like we have a test or a quiz. In fact, our very first quiz for this class will take place on Friday, January 26th.
Is that next week or the week after?
It's the week after. Okay? That's what we got. Plan this out. All right. So, a couple of you are talking a little too much. So let's take a look at these, and I'll zoom in on these properties so we can see them a little bit better. Okay. I know it's a little bit blurry. You have it on your sheet, but we have x raised to the m power times x raised to the n power. So x is called your base. You have a base of a number, or it could be a variable. And it's raised to another variable. And so if we have the same bases, which we have an x, same base, right? And an x raised to the m times x raised to the n, you add the exponents together. So when exponents are when the bases are next to each other and each of the bases are the same, you have the same exponent, you just count them up, you add them. Okay? And then you have a property where you have parentheses, so we've grouped something. We have a base of x, it's raised to the m, and then it's raised to the n. So when exponents are raising each other or on top of each other, they multiply. Okay? So when you have the same base, and I'll do a couple examples here in a sec. I'll go back on this screen so we can kind of take a look at it. But when you have the same bases being multiplied together and each of your bases has some exponent, you add the exponents together. So when exponents are next to each other, you count them. And then when exponents are raising to each other, so you have a base and it's raised to the exponent, and then that is grouped somehow and it's raised to another exponent. So when they're on top of each other, they multiply. Feel okay? So let's just, for sake, we're going to take just a couple of problems and see if we can make this a little better. So let's say we had a base of 3, and it's raised to the 5th, and a base of another 3, and that's raised to the 7th power. So I have the same base, both being 3. Agreed? One of the bases is raised to the 5th power, which is the same thing as saying 3 times 3 times 3 times 3 times 3. And one of them is raised to the 7th power, which is like saying 3 times 3 times 3 times 3 times 3 times 3 times 3. So following our property, which is this first property here, the exponents are next to each other, so we count them. So it's 3 raised to the what power? 12. 5 plus 7 is 12. And then what is 3 to the 12th power? I don't know. It's 3 times itself 12 times. It's probably a pretty big number. Okay. So sometimes exponents, the problem with exponents, a lot of times it becomes too large of a number for your calculator and becomes too large pretty quickly. Okay, because if you think about this, 3 to the first power is 3. 3 to the second power is 3 times 3, which is 9. 3 to the third power is 3 times 3 times 3, which is 27. 3 to the fourth power is 3 times 3 times 3 times 3, which is 81. 3 to the fifth power is 3 times 3 times 3 times 3 times 3. It's now 243, and it keeps going. So 3 to the fifth power are already 243. We still have 7 more to go. Okay? So sometimes an answer like this might be completely acceptable. If you try and plug it in on your calculator, sometimes it'll say error and overflow. All that means is the number's too big. Okay, your calculator does have an end point on it that it will iterate up to and then say, I can't go any further. Yeah.
How would we, like, if we do get an error?
Then I would just leave the answer as 3 to the 12th and call it good. Okay? And again, I don't know if this is too big of a number. I'm just saying that it could be a very large number. Yes?
This is for the first one that we circled?
Yep, so that's for the very first one. And so that's just an example. And there's going to be a page that we're going to go to. We're going to take a look at them. But I just want to do a couple examples. Now, let's take the exact same base, being 3, and let's raise it to the 5th. And then I'm going to group that, and I'm going to raise it to the 7th. So now the exponents are on top of each other. So what mathematical property does it appear this talks about? Multiply. So I multiply the exponents. So 5 times 7 is 35. So I get 3 raised to the 35th power. Okay? So let's do a little cross-curricular. Let's talk a little bit about, let's have the, whoa, he just went there. Okay? So I said when exponents have the same bases, and they're next to each other, you count them up. Should we add them? Right? Does that make sense? And I said if you have a base and it's raised to an exponent, and it's grouped and it's raised to another exponent, so the exponents are on top of each other, they multiply. Okay? Y'all still with me? So cross-curricular, here's your biology lesson for the day. Exponents are like bunnies. You with me?
Yeah.
Take the earbuds out, please. Exponents are like bunnies. So y'all know that you could probably go anywhere when, and I know we had like 6.5 seconds of winter, and now we're into spring, it seems like. Who knows? But you could probably go anywhere to any of these surrounding neighborhoods, including on this campus, or you could go over to the reservoir, and you might see a whole bunch of bunnies. Yes? So when these bunnies are next to each other, you count them up. You add them. Right? Say, oh, I just saw 6 bunnies over there and 8 bunnies over there. So the bunnies is the exponent. But when exponents are on top of each other, what do they do? Let's see if you can make a drive. You got it? Wait, you got it? He might have it.
You said multiply.
That is right. So again, I said exponents are like bunnies. Did I not? When they're next to each other, you count them up. Explain it to your neighbor if they haven't figured it out yet. You're right. When they're all next to each other, you add them up. When they're on top of each other, they
Multiply.
There you go. Everyone understand? If the neighbor next to you doesn't understand, perhaps.
I don't get it. Do you get it? Wait, Preston, explain it to me. I don't get it.
All right. So let's see what this next screen is. So we're only focusing on these first 2 properties, and so, whoops.
Oh my god! That's so bad.
Just saying, you'll never forget it now.
That is
So-
so true. That is so smart.
So let's circle this first property. Let's circle this first property.
This one, the next page?
Yep. So just put a circle on the next one, and then we're going to go back and forth. Let's see, what's this page? We're going to go find that page. So which one did I circle?
The first one.
I have same bases being multiplied. Both those bases have an exponent, so they're next to each other, so they add, right? We count them up. So we're going to take a look at our grid up here. And let's see, are these bases next to each other being multiplied? No, they're being divided, so that's not the property we're going to focus with. What about this next one? I have x to the 13 and y to the 2nd. is if I have an x as a base and I have y as a base, are they the same bases? No, they're two different letters. Do you agree? So that's not a property. Oh, but look at this one. I have a 5 and a 3. Well, I would just be multiplied. We'd go 15, right? And then I have, if I have x just sitting there, what exponent would it be raised to the first? So I have x to the first and I have x to the first. Like bases, they're next to each other, so we count them up. So how many x's, what power are x's going to be to? To the second. Good. And then I have y standing alone, so that's y to the first. And I have y to the second. So same basis, being multiplied. What do we do with the exponents? We count them up, we add them. Okay, so that one's definitely like our first property. Does that make sense? Okay. So I have 15x squared and y to the third power. So I had x to the first, we add them. Y to the first, y to the second, we add the exponents. No, we're done. Oh, yeah, you count them up if that was the case. This fourth problem, I have a negative exponent. Does that satisfy our first property? No, we have a negative exponent, so let's skip it. Okay, this one we'll come back to. This one, so this is going to be similar to the second property, but we're not there yet. This one I'm dividing them, so we're not going to use it. This one I have a negative exponent. I also have a negative base, agree? I have negative 3 raised to the negative 2. So I have a negative base and a negative exponent, but we're not going to deal with that. I have an exponent raised to the 0 power. I'm not going to deal with that today. This one, I have x to the third times x to the 8th. So I have the same bases being multiplied. What do I do with the exponents? Add them up. We count them up. So 3 plus 8 is 11. So x raised to the 11th power. This last one, I have z to the second raised to the 7th. So we'll get to that today, but we're not dealing with that exactly. Dividing them, that doesn't look like today's. Oh, this one looks like today's. I have 2x squared and 3x squared. So what do I do with the 2 and the 3? Multiply, so I get 6. And then I have x to the second times x to the third. So x to the second, x to the third, I do what to the exponents? I add them, so what's 2 plus 3? 5. Okay? This next one here, I have z to the fourth times z to the fifth, same bases, being multiplied. What do I do to the exponents? We add them up, we count them up. So 4 plus 5 is 9. So z to the 9th power. This one here is a power to a power. Let's not work with it. Power to a power. Nope. Dividing them. Nope. We're here. Not yet. Because those don't look like same bases. We are going to get to that. That'll be our next little thing. We'll go back through and do the same thing. I got to look on a paper. I don't know. I can't see that. It's all blurry to me. So that is, this one appears to be, yeah, it just, okay, so that's negative 3x to the 11th times 5x squared, right? So what's negative 3 times 5? What's negative 3 times 5?
Negative 15.
Good, negative 15. And then I have x to the 11th times x to the second. Exponents are next to each other, so we add them up. Add them up. X to the 13, good. Okay? And the exponent, the base is raised to the exponent. The number's not at this point. This one, yeah, that looks like one of ours. Hey, let me ask you all this. What is being squared on this problem? 2. The only thing being squared on this problem is the 5. So 5 squared is what? 25. So the answer here is going to be negative 25. Now, before you argue, look at this next one. See how I have it grouped? So this one, I am taking negative 5, and I'm going negative 5 times negative 5, and a negative times a negative is a positive. So 5 times 5 is 25. So let's just pause there for a moment. Take a look at what we have between those two problems. I have a -5 as and squaring it, and then I have -5 as a quantity that I'm squaring. So one of the answers is negative, and one of the answers is positive. And if you have a calculator, I would ask you to double check. Because if you go on your calculator and you hit the negative key, it's not the minus key, it's the little negative. You go -5 and then you hit the square button, that's your x squared, you're going to see something that's going to take place. Let's see, I probably will bring mine up. There we go. Of course, it hasn't been warmed up for a while, so it might take a second or two to bring on up. So, -5 squared, where the negative is not grouped with the 5, you're just squaring the number. Okay, so if we look on our calculator, if I did this, let's close this, we don't need to learn more. Let's quit out of this. So if I go -5 squared, look what happens when I hit enter. -25. Didn't we just say that?
Yeah.
But if I put this in parentheses, if I go -5 in parentheses, and then I square it like this, note what happens. Huh? Because the only part of the problem that's squared on the first part is the 5. The negative comes along for the right. On the bottom one, I have -5 grouped together. So I'm holding it together with parentheses, and I'm going to square it. So there's one answer that's positive, one that's negative. Guys and girls, remember I said there's a lot of times, as a teacher, we know that there's certain errors that take place often. This is one of them. Okay? So we'll focus on that quite a bit. Okay? So does everyone feel comfortable? At least we've seen this. Right? All right, so what about this one? I got power to power. I'm not going to worry about it. I have a negative exponent. Not going to worry. I'm dividing them. Not going to worry. I have an exponent raised to the 0 power. I'm not going to worry about it. I'm dividing them. Not going to worry. Raised to the 0. Not going to worry about it at this point. Yeah, what do you think? Is that like one of the ones we're going to do?
There's no common variable.
Right. But this one is its own answer. Uh-oh. I hit the wrong part. Hit that. Go back to blue. So this answer here is itself. Oh, wait. Because it has a negative exponent. Nope, we're going to go away from it. We're going to ignore it. I'm sorry. I got excited. This one we're dividing them. Go away. Divide, no. Power to a power with negative exponents, go away. Scientific notation, go away. Scientific notation, we're not going to deal with yet. Dividing them, we're not going to deal with. Scientific notation, not yet. Oh, is that c to the 8th times c? If c is by itself, what is c raised to? 1. So that is c to the 8th times c to the 1st. So like basis being multiplied, what do we do to the exponents? Add them, so this becomes c to the 9th. Okay? Power to power, not going to worry about yet. Negative exponent. Oh, can we do this one right here? So 4 times 2 is? 8. And then I have x to the 2nd and x to the 9th. Same basis being multiplied. What do I do to the exponents? Add them. I count them up. X to the 11th. I have an exponent of 0 I'm not going to worry about. I'm dividing them. I'm not going to worry about yet. I'm dividing them. Not going to worry about yet. Dividing them, and negative exponent, not worry about it. Power to a power, and it's negative, not going to worry about it. I have an exponent of 0, I'm not going to worry about it. Exponent of 0, I'm not going to worry about right now. I'm dividing, I'm not going to worry about. Exponent of 0, I'm not worrying about. Negative exponent. Oh, m squared times m squared is? Same basis, being multiplied. What do I do with the exponents? M to the 4th. Add them up. Power to a power, not going to worry about yet. And then scientific notation, not going to worry about yet. Okay? So those are all that very first property. Okay? You have like bases being multiplied, so you add the exponents. You count up the exponents. Okay? Any questions on any of those? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems. Seem okay? All right, let me go back to this sheet. So we had circled this one, and I'm going to change colors. If you have a different color, awesome. If not, let's maybe box these ones in. So this is a power to a power where both the exponents happen to be a positive number, like 3 and 7 or something like that. So again, we're only focusing on the first two properties. There's 7 properties of exponents, but we're only going to focus on the first two for today. So all of these problems I'll do in green. I can't decipher the difference between blue and green. I apologize. Okay, so power to a power. First one, I'm dividing them. I'm going to not worry about. Second one, I'm dividing them. Not going to worry about. Negative exponent, not going to worry about. Ooh, I have power to a power. D squared to the 5th. Exponents are on top of each other, so what happened? They multiply. So d to the 2nd to the 5th is d to the 10. Oh, but I have d to the 0. So that's as far as I can go on this one for right now. So we'll actually come back because I realize we have a 0 exponent, so we're not going to worry about the rest of that. We'll probably have to finish that up later. Dividing them, not going to worry about. Negative exponent, dividing them, no. Oh, power to power. Z to the 2nd to the 7th. Exponents are on top of each other, so they multiply. So z to the 14. Okay. So that's really only the first one we could do so far. Can't do it because we're dividing them. X to the 2nd to the 4th. So exponents are on top of each other, so they multiply. X to the 8th. Okay. Oh, okay. This is grouped. Do you agree? So I have 2x to the 4th.
Yeah.
But what all is being squared? And how do I know it's all being squared versus just what's on that problem that's indicating parentheses? Okay. So the parentheses mean this comes here, so I get 2 squared, which is 4. And then this comes here. Power to power. X to the 4th to the 2nd. Excuse me. Power to a power. They're on top of each other, so they multiply. So x to the 8th. We're not going to worry about this one because they're dividing. Oh, I think I can do this one. So we did just the one that's kind of similar to this. So this 2 squared is 4. And x squared squared is x to the 4th, okay. And then here, 3 squared is 9. And x to the 3rd to the 2nd. X to the 3 to the 2. X to the 6th, okay. Now this is like the last property. This is like the blue property now. 4 times 9 is 36, agree? X to the 4th, x to the 6th. Same base is being multiplied. We add or count up the exponents, so x to the 10th. Okay, so 36x to the 10th is that one. Here I have a negative exponent we're going to ignore. We have an exponent that's negative and on the bottom we'll ignore for now. It's raised to the 0 we'll ignore for right now. A negative exponent and a fraction we're going to ignore. To the 0 we'll ignore. Negative exponent we'll ignore. We'll ignore this one. We'll ignore this one. This one we'll ignore. Or wait, yeah, we'll ignore that one. Scientific, we'll ignore that for now. Scientific notation, I'm going to ignore for right now. That says a fraction we'll ignore. Scientific notation we're going to ignore. Ooh, okay. Can I get to this one? So I have a power to a power, agree? So I have x times y, and y is to the 4th power. The whole thing is grouped, so that means that this second exponent comes here and here. So x to the 1st to the 2nd, x raised to the 1st, raised to the 2nd is x to the, no, multiply them. So it's x to the 2nd. And then I have x to the 4th to the 2nd. Power to power, we multiply them. So y to the 8th. Did I do that right? A to the negative 4 we're going to ignore. 8y to the 0 we'll ignore. X to the 12th over x to the 7th we'll ignore now because it's a fraction. 15x squared y to the 4th over 10x squared y to the negative 5th we'll ignore right now because they're fractions. Back down to this one, we'll ignore that. This one is power to the power, but it's raised to a negative exponent, so we're going to ignore that right now. We have a 0 property, so ignore. Raised to 0, ignore. Negative exponent on bottom. 0 property, ignore. Ignore that one. Oh, I think this might be the last way we can do it. So I have negative 2x to the 3rd, all as a quantity raised to the 3rd. So this outside exponent comes here. So that's negative 2 to the 3rd, which means it's negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is positive 4. Positive 4 times a negative 2 is negative 8. And then I have x to the 3rd to the 3rd. Exponents are on top of each other, so they multiply. So x to the 3rd is x to the multiply. 9. Okay? So, yeah. Because I was negative 2 to the 3rd, which is negative 2 times negative 2 times negative 2. Yep. One page. So, like bases, a base can be a number, a base can be a letter. If it has an exponent, you add the exponent. You count them up. If you have a base raised to a power, and then that's raised to another power, you multiply. Okay? So I'm going to hand, this is probably the first 5 homework assignments. And this is all I'll print out for you, so it's your responsibility to get over to our Bare Necessity store probably by, at the latest, Tuesday next week. Okay, so I give you a week from today to go get the book. It's $5. If it is a financial concern, you don't tell me. You go to your counselor and say, hey, $5 is too much. Can't afford it. I realize I have an iPhone 19 in my hand that costs $68,000. But $5 is too much. I'm just being facetious.
This is homework for.
No. This is like the first 5 homework assignments. So, all right. So, your homework assignment. So what you'll have to do is when you turn this in tomorrow, you'll have to separate this. The first page doesn't have a back to it. So you need to do the first page. I will tell you that sometimes you might come across a negative exponent, but you know a negative times a negative is a? Okay, so like number 17, you have y to the negative 2 to the negative 3. If you multiply negative 2 times negative 3, you get positive 6, so you might be able to do that. Okay? Problem number 21, you also might be able to do that just by thinking about it. You have base raised to an exponent times base raised to an exponent times base times an exponent. So you add up the exponents. So if you added 4 plus negative 6, you get negative 2. And negative 2 plus 7, you get positive 5. So you might be able to do some of those. So 1 through 26 are your assignment. Okay? And then while you're thinking about that, how do I mark off homework assignments? What's my yeah, so come tomorrow, you have your page 1. I think it says page 1 down here. You have your name on it. Okay? Please print first and last. Sometimes if there's like, 5 Jacks in the same class, it kind of gets hard figuring out whose Jack is Jack is Jack. So first and last name. Then I'll come walking around before, say get your homework out, and I'll come by and I'll either do that, which means you tried what? Tried all of it. Tried all of it. I give you that. You did half to 3/4. This, less than half was tried. This is worth 4 points. This is worth 3 points. This is worth 2 points. You know what stinks at the end of a semester? When you have the student with a 58%, I go back and look at homeworks and I see 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Guess what that 58% would have been if they would have tried a little bit harder just to get a 3, 3, 3, 3, 3, 3. It would have been a D. So there are people that have failed CP Algebra 1 because, homework's not important. Okay? If you're not a good test taker, make sure you're putting forth and you are trying every problem. Does try mean you got every problem right? No. You tried it. And trying a problem isn't this. I could have drawn this dude with a smiley face with eyebrows that look funky. Okay, that's not trying. Okay, apply the principle. If you get it wrong, so what? We'll go over it, adjust it, good. Turn it in, get 4 points. Okay, get the middle mark, get it done, turn it into me, I'll give you 3 points. Get the bottom mark, get it done, turn it into me, I'll give you 2 points. Well, if I get it done, I should get 4 points. No, because you didn't get the whole thing, you didn't try the whole thing in the beginning. Sound good? Perfect. Hey, what